All right, welcome to the video where we are going to learn how to convert between moles and mass. So what you should probably be aware of is that anytime you put anything on a scale, you're going to get its mass. And if I were to put myself on a scale, let's make a very plump looking guy, right? If you're if only I'm a snowman with arms and legs equally well drawn on one of these industrial style scales, if I put myself on that scale, you could come up with a mass per fat guy ratio. And you could end up with something to the effect of, this is horrifying, 315 pounds per fat man, right? So that's a conversion factor, right? So if I told you that I had two identical fat men, right, couldn't we then figure out how many pounds that would be? But what if I put a dozen of me on a scale? Couldn't you come up with a conversion between a dozen fat men and their mass? But how about this? What if I took a really, really large scale, right, and I put 1 mole of fat guys on here? Now, I'm going to draw like 3. That's going to represent 1 mole. Do you guys remember the number for 1 mole? That way, guy evidently has a really long neck. Isn't 1 mole 6.022 times 10 to the 23rd? So if I took 6.02 times 10 to the 23rd fat guys, I can end up with a mass for that many guys. So pretty simply, if I put a mole of anything onto a scale, I'm going to end up with its mass. And we call that the molar mass. And it kind of makes sense because it's the mass of 1 mole of that thing. Now, how does that play into elements and atoms? Well, on our periodic table, we have this really cool thing underneath, and I'm going to change color here because that makes things better. If you take a look, underneath each element, you have this number right here. And that number, it's known as the average atomic mass, and that's actually the average of all the isotopes masses. Shock to the past. But we also can call that the molar mass. And what that really is that's the mass of 1 mole of atoms in grams. So if I took 1 mole of mercury and I poured them all onto a scale, so I had a really big scale, right? And I put 1 mole of mercury onto that scale. That's 6.2. Remember, this is 6.022 times 10 to the 23rd. I know this is horrible drawing. If I put 6.02 times 10 to the 23rd atoms of mercury onto that scale, they would have a mass of 200.59 grams. So what we have now is a conversion factor for every single element on the periodic table. One that we use commonly is carbon. If you take a look here, you see how the molar mass of carbon is 12.01. What that means is if I took 1 mole, or 6.022 times 10 to the 23rd atoms of carbon, and I put it onto a scale, it would have a mass of 12.01 grams. So let's go back here and let's work with this a little bit more. Let's go back to our fun color. Let's maybe go with a green. I don't know if that's going to be fun at all. We'll tell. So whenever we have the mass of a mole, we call that the molar mass. And the units are always grams per mole. And if you have grams per mole, that means that you know this. You know the number of grams that are equal to 1 mole, which means you could write grams per mole, or couldn't you write moles per gram? We've done this often, anytime. If we had, for example, 12 inches equals 1 foot, couldn't we then put 1 foot on top of 12 inches or 12 inches on top of 1 foot? So let's take the example of carbon right now, and let's go back and take a look at its molar mass. So doesn't the molar mass of carbon say 12.01 below it? So that's 12.01 grams per mole. I don't like this color very much, so let's just switch over to a nice little blue color here. So if I have this, and I have carbon is 12.01 grams per mole. So that's, I forgot to put a little C in here. For every 12.01 grams of carbon, you have 1 mole of carbon. Which means that you could, if you wanted to, couldn't you write it in the reverse and go for every 1 mole of carbon, there's 12.01 grams of carbon? That's because in all eventualities, 12.01 grams of carbon is equal to 1 mole of carbon. That is a conversion factor. And what that does, that allows us to do some mathematics. So if I wanted to, I could do a simple mathematics problem where I went like this. I'm going to make this really simple for myself. So let's say I told you that I had 48.04 grams of carbon, and I wanted to know, hey, how many moles of carbon is that? Well, as we often do, we start off by putting our initial value into a table. So we'd go 48.04 grams of carbon. We'd put that into our table, and then we'd find a conversion that takes us from the unit we have to the unit we want to get to. And that, of course, is molar mass. So anytime you want to go between grams and moles, or moles and grams, you're going to use molar mass. And the molar mass, which we got from the periodic table, let me remind you again where we got this from. That's this 12.01 right here. That is 12.01 grams per mole. Now the question is, how do we put it in here to cancel out grams? And since grams are on the top, we're going to have to go 12.01 grams on the bottom of carbon for every 1 mole of carbon. Now, I did this specifically because I wanted these units to be able to cancel out. So grams, see here how they cancel out here? And you see how the unit that I'm left with is moles, which is the unit that we were looking to solve for. So over here, I'm going to write, oh yeah, I have moles of carbon. If I then do the math, remember that this line right here, any line like this means multiply, and any line like this means divided by. So I'm going to take 48.04 and times it by 1, but come on now, right? And then I'm going to divide it by 12.01. And when I do that, I'm going to get 4.000 moles of carbon. Now, in this particular problem, I gave you 4 significant figures to start with, so I have to have 4 significant figures in my answer. That kind of makes sense? But here's the problem. We don't always deal with just individual atoms. Sometimes we deal with atoms that are together. We call those molecules. So if we ever have a molecule and we want to figure out its overall molar mass, we take all the individual molar masses and we add them together. So by adding the individual molar masses, that's supposed to be adding, we can get the overall molar mass. Again, this is a pretty straightforward concept. If I were to take a fat guy, right? There's a fat guy, and I were to take a skinny guy, right? And I were to put them, and I want to know, hey, how much did they weigh combined? None of us is going to say, well, just take the fat guy's mass and multiply it by 2. Nor would you say, take the skinny guy's mass and multiply it by 2. Wouldn't you put them on, again, industrial size scales, and couldn't you take the mass of this guy and the mass of this guy and add them together? Wouldn't that give you your total mass? Well, the same thing works. When we have a compound like, let's say, CO2, right? Do you see how it's made up of 1 carbon and 2 oxygens? So if I have a periodic table, which I do, and I have the molar mass of carbon is 2.01, or 12.01, and the molar mass of oxygen is 16.00, couldn't I add them all together to get the overall molar mass of carbon dioxide? So let's add up all the things that are together. So couldn't I go, well, we have 1 carbon, right? And then don't we have 2 oxygens? So what does that lead us with? Well, each carbon is 12.01 grams per mole. Remember, the units for molar mass are grams per mole. Each oxygen is, let's put an arrow here to be uniform, is 16.00 grams per mole. Well, don't we have 2 of those though? So we have to multiply the oxygen number by 2. And then we just add them together. So these both have to be added. And if I add these all together, I end up with 44.001 grams per mole. That is the molar mass for carbon. So I could then, if I told you the number of grams of CO2, I could use this conversion right here to figure out the moles and vice versa. But what if we end up with one that looks a lot more ugly, like this one over here? Well, let's keep track of all the things that are in here. So let's take a look here. Would you agree with me that we have 1 Ca? But then here, do you see how this Cl over here, isn't it being multiplied by this 2? Because remember, anytime you have parentheses, anything on the outside of the parentheses multiplies by everything on the inside. So I'm going to have 2 Cls, right? And then I'm going to have to go 2 times 3. That's going to be 6 Os. So then I have to look on the periodic table and find out what are the molar masses for each of these. Now on the periodic table over here, we can take a look and we can see that calcium is 40.08 and chlorine is 35.45. right? So if calcium is 40.08, let's go back down here. Sorry, I feel a little bit dizzy. So we have 40.08. And isn't chlorine 35.45? But don't we have to multiply that by 2? And then don't we have 6 of these oxygens, and each of the oxygens is 16.00. So we have to add all of these together. And when we do, I'm going to do this kind of on the side. I know that 6 times 16 is 96 because, that's old school mathematics we had to do. This is 40.08. Again, that's supposed to be a 0. That's supposed to be an 8. It's kind of getting a little wonky there. 35.45. If I multiply that about twice, that's going to give us 70.90. So I'm not good enough to do all three of these all three of those in my head. But I just looked back at that. That is really messy. I apologize for you having to watch that. But I tried today to use a pen virtually versus doing a pen on the paper like I've done in the past. So if I go 40.08 and I add that to 70.9 and I add that to 96, altogether I'm going to end up with 206.98. So that 206.98, that is the grams per mole of this compound. Now, how can we use that? Well, we can do the same type of problem we did before. So let's say I gave you 120 grams of a compound and I asked you how many moles. Well, now I want to go from grams to moles, and the only way we can ever go between grams and moles, or moles and grams, is by using the molar mass. Now, fortunately, and because I planned this, we just figured out the molar mass right above here of CO2 to be 44.08 or 44.01. So I'm going to start up and set up our table like we often do. I'm going to go 1220.0 grams of CO2, and I'm going to put that in the upper left-hand corner of our table. Then the only question is, what do I do with this 44.01 grams per mole? Now remember, I can put either, and if you want to be logistic about it, do you realize that that's 44.01 grams per 1 mole of this? So I can either put the mole on the top and the grams on the bottom, or vice versa. And since I have the grams on the top and I have to cancel, I'm going to go 44.01 grams of CO2 on the bottom, and I'm going to put 1 mole of CO2 on the top. Let me remind you again, when you're doing molar mass, if you have a number other than 1 next to moles, you've done it wrong. So again, we have 120 on the top. We're multiplying by 1 because remember, this line right here means multiplication, and this line right here between these two means division. So essentially, I could go 120.0 times 1, but come on, man, right? 120.0, and we're going to divide that by 44.01. And when I do that, I'm going to get this long number. I'm going to write it all out here for your viewing pleasure. I'm going to get 29.925. Now, if you take a look here, weren't there only 4 significant figures right here? And I don't want us to get out of the habit of using correct significant figures. So my computer is lagging a little bit here, so this could be a little bit problematic. So I'm going to count over 1, 2, 3, 4. I'm going to cut off right here, and that means my final answer is going to end up being 29.93. And this is really important. When we're canceling out units, we need to truly cancel out units. So the grams, they leave, right? The only unit left is moles of CO2. So you cannot leave this number standing here by itself. You have to write moles of CO2 as the unit on the end. Let's try one more. Let's make use of this really ugly molar mass right here. I'll box this because that's what we're using right now. And the problem is going to be this. Start with 2.21 moles of the Ca, boy, my pen is really having issues, CaClO3 in parentheses 2. And we're going to set up our table like we normally would. Now, we already have the molar mass because we figured it out here because we're wanting to go between moles and grams. And just a reminder, anytime we go between moles and grams or grams and moles, we are using molar mass. Well, we figured out our molar mass to be 206.98. I got kind of lazy with the significant figures here, so I'm going to leave them all in just because I can. In reality, wouldn't this have probably, because we used 4 significant figures in all these, shouldn't have probably been 207.0, but I'm going to, in fact, let's just do it as 207.0. So since I have moles on the top right now, that means this. I'm going to have the 1 mole on the bottom, and then I'm going to have my 207.0 grams of CaClO3 in parentheses 2 on the top. Now, I'm having kind of a hard time writing this. I'm going to put this same unit down here below. We got to cancel out our units, right? So if I cancel out my units, see how moles will cancel out with the moles here, and the unit I'll be left with is this, grams of the CaCl3. Now, I still have to do my math, and see I have to multiply these two things on the top by each other. So when I do that, I'm going to end up with 2.21 times 207.0, and we're going to get 457.47. Now, in this problem, I started off with only 3 significant figures, so that means I'm going to have to cut off my significant figures right here. So my answer is going to end up being 457 grams of CaClO3 in parentheses 2. Hopefully this has made a little bit of sense. We'll be definitely going over this in class. That's all I have for now. I'll see you in the next video. Thanks. Bye.